Hey everyone, and welcome back to this class, the NumPy stack in Python. In this lecture we are going to look at how to plot images. When you see an image file on your computer, you might think it's magic. But in reality, an image is still just a matrix of numbers. Each value in the matrix is the intensity of that pixel at that position in the image. Of course, if you open a JPEG or a PNG file on your computer, you're not going to see these numbers because these image formats make use of compression. However, when you decompress the image, you get back a matrix of numbers. The images we'll be looking at are from the famous MNIST dataset. These are small images of handwritten digits. The format will also let us explore a few more NumPy functions. To get this data, you'll want to go to kaggle.com/c/digit-recognizer and click on the link that says Data. I'm going to use train.csv in this particular tutorial. For most of the examples in my courses, whenever we need a huge data file like this, we won't want to store it in the class repo on GitHub. Otherwise, it would take a very long time to download. Usually, the data will be stored in a folder adjacent to all the class folders called large files. So make sure you put train.csv in that folder. Now, if you look at the actual CSV, you'll see that there is a big header row. Alright, so it's pretty long. The first column is the label, which we won't need in this course, and the rest are the pixels. You'll notice that there are 784 pixels in total, numbered from 0 to 783. This is because the MNIST images are 28 by 28 images, and 28 times 28 is 784. So the image is flattened into a vector in order to store it as a CSV. So let's go back to our code, import pandas, and let's load in the data. So I'm currently in the folder NumPy class, so I need to go back out and go into large files. So that took quite a while since the data set is pretty large. We can check the shape of the data frame so we know its size. So we can see that there are 42,000 samples and 785 columns, where one of those is the label. So let's first turn this into a matrix. Keep in mind that the goal is to display an image. We can grab the first image in the data set by doing this. So this means select the 0th row, meaning the 0th sample, and give me all the columns except the column at position 0, since I know that's not a pixel. I can check the shape of IM, and we see that it's a vector of size 784 as expected. But what we really want is a 28 by 28 matrix, which represents an image. Luckily, NumPy has a reshape function that does exactly this. So let's call that function. And we can check the shape again, just to be sure. Now we are ready to plot the image. So that's plt imshow of im. Right, so we need to import matplotlib again. Okay, so this looks a lot like a 1. We can check the label, and it is indeed a 1. Notice how the colors were a bit weird. It looked more like a heat map than an image. If you want to display the image in black and white, as would be natural, you can do imshow im and set the color map to gray. plt.show. So now it's in black and white. So here black corresponds to a pixel value of 0 and white corresponds to a pixel value of 255. Note that you could also plot the inverse so that the pen markings are black and the background is white, since that would be a little more natural. So you could do plt.im show 255 minus im. CMap is gray again. We show that. And now we have black pen markings on a white background.